Bismillah ar-Rahman ar-Rahim. Chapter 4. Chapter 4, we have two main subjects, exponential function and logarithm function. Also, we have some subject like one-to-one function, how can find the inverse to the function, how can solve the exponential and logarithm equation also. Okay. Now, firstly, we will start with inverse function. Inverse function means if we have the point, for example, a and b to the f of x. So, if the function f have inverse denoted by -1 in the power, and the point swap between x coordinate and y coordinate. This is the inverse function. If the point AB, for example, 1, 2, belongs to the function f, so BA belongs to the inverse function and denoted by f to the power inverse -1. Firstly, before the starting with inverse, we have main condition to find the inverse. This is one-to-one function. One-to-one function, the function have each, this is the domain, this is the range. The one-to-one function means any A or B or C, any point in the domain have the image in the range but different with another point or another value in the domain. So cannot find A and B different but FLA equal FLB. So the main condition for one-to-one function, if A and B are different, not equal, so FLA and FLB must be the different also. Okay, some example for non-one-to-one function. Some example, for example, f of x equal x squared. Okay, look at the -3 and 3. This is not equal, but f and -3 are equal with f L3. This is both equal 9. So this is not one-to-one, not 1-to-1. Why? Because have two different value of x, but have the same f of x. The same value of the f of x. -3 not equal 3, but f -3 equal 9, f L3 equal 9. Okay, so this is not one-to-one, f x squared. If we need to find or check one-to-one in the Bears point like this in f and g, look at the, we have 1, 2, 6, and the y coordinator 3, 4, and -2. This is different. So we have each value in the domain have separate value in the codomain or the range. Okay, but in G not one-to-one. Why not one-to-one? Look at this. We have 1 and 6. 1 link with the 3 and 6 link with the 3 also. So we have 1 not equal 6, but FL1 equal F as 6, both equal 3. Okay. Also in the Venn diagram, we have 1, 2, and 6. 1 connect with 3, 2 connect with 4, but 6 also connect with 3. So we have different point in the domain connect with the same value in the codomain. Okay, so this is not one-to-one, but in F 1, 2, 6, 1 connect with the 3, 2 with 4, and 6 with -2. So this is one-to-one. Okay, how can verify the function is one-to-one or not one-to-one? Look at this. If A equal B, FL A equal FL B, we must show in A and B are equal. This is if we need to check the f of x is one-to-one or not one-to-one. For example, about this, wait. Example, verify f of x equal 2x minus 3 is one-to-one or not. The solution is, firstly, put it FLA equal FLB. FLA equal FLB. So substitute FLA, we have 2A minus 3 equal. Substitute B, we have 2B minus 3. Now we can remove 3 and then -3 with -3. So we have 2A equal 2B. Also, we can divide both sides by 2. So we have A equal B. If we start FLA equal FLB and the end or show that A equal B, so f of x is 1-to-1 function. Okay, any question? Also, we have another method to check is one-to-one or not one-to-one. By what? By the horizontal line test. Horizontal line test means if we have the graph of any relation or any function and we need to show that this graph is one-to-one or not one-to-one. So put it the horizontal line like this, horizontal line. If we have one of horizontal intersection with the graph with more than 1 point, so this is not one-to-one. Look another graph. We have many horizontal line, but each horizontal line have intersection 1 point with the graph. So this is one-to-one function. This is another method to check the f of x is one-to-one or not one-to-one by horizontal line test. Any question about this test also? Any question? Okay. Now we already studied the composition function. Okay. When we study the functions, we already studied the composition function. F composite G, this means what? F, and we need to substitute G of X in F. F composite G. But G composite F, we need to substitute F of X in the function G. Okay, so if the composition function F composite G equal X and G composite F equal X, we can conclude F inverse للG and G inverse للF. So if G inverse للF, this means G equal what? F inverse. This is G X equal F inverse of f of X. Okay? Because the composition function F composite G and G composite F equal X. So this is the main rules. F composite F inverse of X, this is equal X, must be equal X. And F inverse composite F also equal X. Okay? Now, how can find the inverse? Before that, to find the inverse, any function 1 to 1, okay, or sorry, any function have inverse must be 1 to 1. Any function have inverse must be 1 to 1. A simple example about the inverse, if f of x equal like this, 1 with 2 and 2 with negative 3 and 3 with 0. So the inverse function equal what? We have 1, 2. So an inverse must be 2, 1. If we have point 2, negative 3 in the f of x, and the inverse must be negative 3, 2. So swap between x and y coordinate. Also, we have 3, 0, and the inverse equals 0, 3. Okay? This is the value of f inverse if we have f of x inverse order points. Okay, in general, how can find the inverse? Firstly, we must replace between f of x and y. So remove f of x, put it y. So the equation y equal, for example, 2x minus 3, like this. Okay? Interchange between x and y. If we have x, replace it with y. If we have y, replace it with x. Now we need to find the y equal. So we need to keep the y in one of both sides alone without any coefficient, without any addition or subtraction or division or multiplication. Now, if we found the y, this is the f of inverse. This is the value of f inverse. Okay? Example about that. So we have 4 steps. Look at this. We have, this is f of x, and we need to find the inverse. Firstly, replace f with y. So remove f, put it y. Now, this is the first step. The second step, replace. If we have y, put it x. If we have x, put it y. Okay? Okay, this is the second step. The third step, move -2 and divide by 3 because we need to y alone on the in one side. Okay, so y equal x plus 3 over 3. The last step, the y, this y is the inverse, the value of the inverse. So f inverse equal x plus 2 over 3. Okay, another example to find the inverse. Example, find f inverse of f of x if f of x equal 5x minus 3 over 2, like this. To find the inverse of f of x, the solution, firstly, y equal 5x minus 3 over 2. So this is the first step. Replace f with y. Now, the second step, if we have y, put it x. If we have x, put it y. Now, we need to keep y alone in left-hand side or right-hand side, no problem. But we need to solve by y. So we need y equal, not x equal. So the step 3, firstly, this is over 1, so we have 5y minus 3 multiplied by 1 and x multiplied 2, so we have 2x. Move the negative 3 to another side, so we have 5y equal 2x plus 3. Divide by 5, so we have y equal 2x plus 3 over 5. The last step, just replace y with f inverse. This is the value of f inverse. So we have 2x plus 3 over 5. This is the inverse of the function f of x, this one. If you need to check the f, this is f inverse, already inverse of f of x, must be find f composite f inverse of x must be the result equal x, and f inverse composite f must be equal also x, if we need to verify this is inverse or not. Okay, Miral. For example, f composite f inverse, look at this. What's the value of f of x? We need to substitute f inverse. So we have 5 f inverse minus 3 over 2. So we have 5. The value of f inverse equal 2x plus 3 over 5 minus 3 over 2. We can remove 5 with 5. So we have 2x plus 3 minus 3 over 2. Remove 3 with negative 3 and 2 with 2, so we have x. Okay, so this is the value. Also must be check f inverse composite f. So we need to find f inverse and substitute f in f inverse. So we have 2f plus 3 over 5. This equal 2. What's the value of f? 5x minus 3 over 2 plus 3 over 5. Remove 2 with 2. So we have 5x minus 3 plus 3 over 5. Remove negative 3 with positive 3. 5 with 5, so we have x. Okay, this is to check. Must we check this one and this one? Must be check both f composite g and g composite f, or f composite f inverse composite f. Now look at the previous example. This is f of x and this is f inverse. Both want this reflection on the x equal y. This is the reflection on the line. This is the line x equal y. Okay, any point, for example, which one? Look at this point. This point in the inverse equal minus 2 and 0. X equal minus 2, x coordinate, and y equal 0. Must be 0 minus 2 on the inverse. Look at this. This point 0x and minus 2y. Because this is inverse to f of x. Any question? Any question before starting the exponential function? Any question about the inverse? Okay. Now, the exponential function. What's the meaning exponential function? Exponential function mean we have number to the power x, number to the power x, b to the power x. For example, f of x equal 2 to the power x, or f of x equal 5 to the power x, or f of x equal 1 over 3 to the power x, like this. Any number to the power x, but must be positive. The number must be positive. So, for example, minus 2 to the power x, this is not exponential function. Okay. For example, f of x equal minus 2 to the power x, هذا not exponential. This is not a y because the b must be positive and not equal 1, because 1 to the power x equal 1. This is constant, not exponential function. Okay. Any exponential function have increasing or decreasing, this one increasing and this one decreasing. Okay. Both increasing or decreasing any exponential function must be passing through on the 0, 1, on the 0, 1. Okay. If the exponential function increasing, so the b must be greater than 1. b greater than 1. For example, 2 to the power x or 5 to the power x. If the exponential function decreasing, so the b must be between 0 and 1, but not equal 0 and not equal 1, but positive, but between 0 and 1. For example, 1 over 2, 3 over 5, 2 over 3, like this. Okay. So if we have, for example, this is f of x equal 2 to the power x, this is increase, but f of x equal 1 over 2 to the power x, this is decrease. Okay. The domain of the exponential function, the domain from minus infinity to infinity. This is the domain of the exponential function. The range from 0 to infinity. The range, the value of y from 0 to infinity. This is the range. Okay. And we have horizontal line. What's the horizontal line? اللي هو x-axis. X-axis, this is horizontal line. This called y equals 0. The horizontal line or the x-axis, this is y equals 0. The y-axis, this is x equals 0. Okay, so we have horizontal line اللي هو x-axis or y equals 0. Then horizontal asymptote اللي هو x-axis or y equal 0. This is the horizontal asymptote. Horizontal asymptote means the exponential function close to this line or this horizontal line, but not have intersection with this horizontal line. So cannot find the value of exponential function negative. Cannot find the range from 0 to infinity. So we have the range, all the value of f of x in exponential function positive. So also the exponential function passing through 0, 1. This is the graph, for example, for f of x equal 2 to the power x if b greater than 1, or decreasing if we have b between 0 and 1. This is, for example, half to the power x. Okay? Look at this example. Is x to the power 2 exponential function? Absolutely no, because exponential function must be number to the power x. Okay, number to the power x. So this is not exponential function. We have a rational number. Also, you can find it in your calculator. E. This is natural number or irrational number E. This equal limit at x goes to infinity for what? For the value 1 plus 1 over x all to the power x. This value equal E. E, this is number E, 2.171828. This is irrational number. And so on to infinity, random to infinity. Okay, this is approximate. Now, so also f of x equal e to the power x. This is exponential function. This is exponential function with base e, the number of base e. Okay, this is number e. Now, exponential function for e, this is greater e greater than 1. So we have an increasing, look at this, an increasing function passing through 0, 1. Okay. Now, this is what? This is f of x equal e to the power x. But if we have e to the power x minus 3, so we have shifting to down with 3 value. So we have 1, 2, 3. So we have shifting to down. All graph shifting down 3 times. Okay, 3 unit. 3 unit shifting down 3 unit. Okay, if we have, for example, g of x equal e to the power x plus, for example, 2, this is shifting to up with 2 unit. So we have 1, 2. This is the value of shifting up, like this. This is the value of g of x. Okay, so if we have exponential function plus 2 plus 3 plus 5, so this is shifting up with some unit. But minus 3, minus 2, minus 5, minus 4, so this is shifting to down. Okay. Now, example about the exponential function. This is approximate to the exponential function because this is with n goes to infinity, so we have e. Okay, so if we have $B for a principal is invested or borrowed at the annual interest rate, so this is R interest rate, B the principal, and T with time T years, then simple interest اللي هي بنسميها الفائدة البسيطة إلى آخره. We can calculate the interest or simple interest by this laws. Okay, but the future value of the A with interest bounded, this is interest compounded. Okay, so this is simple, but this is interest compounded with n times per years, n time per year. Okay, so we can use this formula. But if we have interest compounded with continuously without a specific value of n time per year, so we can use this one. So this is for continuously, but this is if we have interest compounded with n time, we can use this formula. But if we have simple interest, use this formula. Now, look at this. Suppose that we have 8,000, so the B equal $8,000 with interested at, so we have R equal 5.4 percent. So this is equal what in the value? R equal 0.054. This is the value of the interest rate. Okay, compute the amount in the account, in your account, at the end of 3 years. Okay, so the T equal 3 under the following compounded options. Quarterly, this is n equal 4. Okay, so we have n equal 4. We can, because this is compounding, so we have compounded interest. So with n, we have n equal 4. So using what? Using the second formula. Put it the value of B, the R, the n, and n multiply t equal 3 years. Okay, so you can find the your amount in your account, okay, after 3 years. But if we have continuously, so without n, we can find the your amount in your account by using this formula. B equal 8,000, E, this is number, to the power R multiply T equal 3. So we can find the compounded interest continuously. Okay, so we have 3 formula. If we need to find the simple interest or compounded interest, we have with n times or continuously. Any question about this example? This is just put in the value of B, of R, of T, of N to find the amount in your account. Logarithmic function. Logarithmic function, this is the inverse of exponential, and the exponential, this is the inverse of logarithm. Okay, if we have x and b positive real number, so must be x and b positive real number, such that and b not equal 1. Then look at this, y equal what? The function x, the logarithmic function equal logarithm lx to base b. Lx must be positive, lb must be positive, lb called base, lx argument, and the y equal, this is the value of logarithm. Okay, so we can convert between this formula and this formula, exponential form and logarithmic form. For example, okay, I need slide and return to this slide. For example, logarithmic form, or first the exponential form, we already know the 2 to the power 3 equal 8. If we need to convert this to logarithmic form, this equal logarithm 8, this is the argument, to base. What the value of base? This is the base. To base 2 equal what? 3. So the value of logarithm, this is the exponent. This is the exponent 3. Inside logarithm, this is the argument, or the value of b to the power a, for example. Okay, and the base of logarithm, this is the base in exponential form. So if we have a to the power b equals c, we can convert this in logarithm c to base a equal b. Okay, like this. Look at this. A to the power b, a to the power b equal what? Equal c. 2 to the power 3 equal what? Equal 8. So, for example, if we have logarithm 5, 2, and this is empty. What's the value in the box? What's the value in the box? 10? Wait, not multiply, to the power. 5 to the power 2, so we have 5 to the power 2. This is the value inside the logarithm. So we have 25. Okay? 5 square equal 25. Okay? So this is the relation between exponential and logarithmic form. Exponential form and logarithmic form. This is the relation between them. This is the inverse together. Exponential inverse la logarithm, logarithm inverse la exponential. Now, back. So, this is f of x, for example, logarithm Lx to base b. We can convert to the gx, b to the power x. This is the inverse together. Okay. Some logarithm, we have two special logarithm. We have two special logarithms. The first one, common logarithm function. If we have the base 10, we can put it the logarithm log without base. So any logarithm without base, this is common logarithm directly. For example, if we have log box equal, for example, 3, so what's the value in the box? What's the value in the box? Not multiply, Ruba, not multiply. This is power, so we have 10. But if we have base 10, we can remove the 10. No need to write the 10. This is already, we know, this is common logarithm. This is the 10. 10 to the power 3, we have 1000. Okay, 10 to the power 3, we have 1000. Also, we have natural logarithmic. Natural logarithmic, if we have exponential, logarithm with e, with the base e, This is too special. If we have base 10, this is common logarithm, and remove the 10. If we have base e, this is the special. This is called natural logarithm, and remove the e and put it ln. So ln الx this is equal logarithm الx للبيس e. This is both, but for simple not put it log e log e. This is ln ln. Okay, ln logarithmic natural function. Okay, so if we have ln, this is natural logarithm with this is logarithm with base e. If we have log without any base, so the base equal 10. Now, if y equal logarithm x to base e in logarithmic form, so this is equal what in exponential? This is equal x inside the logarithm x equal 2 to the power y, 2 to the power y. Okay, look at this logarithm x to base e equal y. So the x equal what? 2 to the power y. Okay, now the value of y is called logarithm. The value of y, this is the value of logarithm. E base, this is the base, and x, this is argument, and this is the result. Okay, result of logarithm. Look at this example equivalent between logarithm and exponential form. If we have logarithm 16 to base 2, this is equal what? 4, because 2 to the power 4 equal 16. Now, this means 16 equal what? 2 to the power 4. Look at this, 2 to the power 4 equals 16. The same, this is 10, but no need to write. So 10 to the power 2 equal what? 100. This is logarithm with base e, e to the power negative 1. Look at this, e to the power negative 1 equal what? Equal inside the logarithm 1 over e. Okay, any question about this slide? Any question? We have important properties in logarithm. This is very important. This is the 4 very important properties. Look at this. Logarithm 1 or lineal 1 always equals 0 for any base. So log L1 equal 0. Len L1 equal 0. Logarithm 1 to base, for example, 5 equals 0. So logarithm 1 to any base, base 10, base e, any base equals 0. Okay. The second, logarithm b to base b equal 1. So for example, logarithm 10, base 10, so we have 1. Because the base equal the argument. The argument and base are equal, so the logarithm equal 1. Len e also 1, because this is logarithm e to base e. Logarithm 5 to base 5 also equal 1. So if we have the argument equal base, so the value of logarithm equal 1 directly. If we have the argument and the base are equal and we have exponent, so the result equal exponent. For example, about this, logarithm 10 to base 3 directly equal 3. because logarithm remove the 10, this is equal 1, and the value 1 multiply 3 equal 3. Ln e to the power 5, this is equal 5. Logarithm 5 to the power 4 to base 5. If we have argument the same base, so the value equal exponent, الأس. So we have 4. Okay. Also, if we have b to the power log to base b, we can remove b with log b and the value equal x. Example, logarithm, 10 to the power log 10 to the power 5. So this is directly equal 5. E to the power ln e to the power, for example, 3. So this is a 3. E remove ln e. A 10 remove log e and log 10. Okay. Also 5 to the power log to base 5, and we have 5 to the power, for example, 6. So this is equal 6. Okay. 5, 3, and 6, like this. So 10 remove log, so we have 5. E remove ln, so we have 3. 5 remove log 5, so we have 6. Okay. Also we have number 5, logarithm base a will be a to the power x or x to the power a. So this is equal, we can put it a outside logarithm x to base b. If we have exponent, we can put it outside the logarithm. For example, if we have logarithm x to the power 3 to base, for example, log 3 is log 10. So we have 3 log x, like this. We can put it 3 and convert 3 from exponent to multiply with logarithm. Also, if we have ln, for example, e to the power 7, this is equal 7 ln e, and ln e equal 1. This is ln e equal 1, so we have 7. Look at this example, log 1 directly 0. If we have the argument and the base are equal, so the logarithm equal 1. Look at this, if we have power, we can put it outside. Ln e equal 1, 5 multiply 1 equal 5. Also, if we have 10 log, also the base 10, so we can remove a 10 with the logarithm, so we have x plus 5. Any question about these examples? Any question? The graph of logarithm, this is depend on the value of the base. So we have two graphs. We have increasing, if we have the b greater than 1, b greater than 1, if we have f of x equal logarithm x to base b, and b, for example, 2, 3 greater than 1, so this is increasing, and basing through 1, 0. If we have be between 1 and 0, for example, 1 over 2, 3 over 5, 2 over 7. So any value of the base between 0 and 1, so the logarithm decreasing, okay, and passing through 1, 0, okay. Look at this example, the base half, so this is between 0 and 1, so we have decreasing logarithm, okay. In general, so like this, b greater than 1 increase, from 0 to 1 decrease. In general, the domain from 0, look at this, to infinity, from 0 to infinity, okay? But the range the value of y. Look at this, the value of y from minus infinity to infinity. This is the range, okay? The domain from 0 to infinity, but the range from minus infinity to to infinity, okay? The asymptote in the x equals 0, the vertical line or x or y coordinate. So the vertical asymptote اللي هو y axis or x equal 0. This is the vertical asymptote. Okay. Each function increase or decrease passing through 1, 0. Okay. Any logarithm must be inside the logarithm x هذه must be positive, greater than 0, positive. This is cannot be negative or 0. Cannot be negative, cannot be 0. Must be positive, okay, inside the logarithm. So, for example, if we have f of x equal logarithm to base 10 with, for example, 5 or 7 minus x, and we need to find, for example, f L3, this is equal what? Logarithm 7 minus 3, so we have logarithm equal 4, okay? But if we need to find f, for example, 10, this is equal logarithm 7 minus 10, so we have logarithm in negative 3. But try to find the logarithm negative 3 to base 10 by calculator. This is not defined or undefined. Undefined. Because the result inside the logarithm, the argument, negative. The argument must be positive. The argument must be positive. The argument. Okay. Now, if the argument must be positive, this is the fact when using the logarithm. We need to find the domain of ln 3 minus x. The domain equal 3 minus x must be positive, greater than 0. Okay, because 3 minus x inside the logarithm. Any value inside the logarithm must be positive. So 3 minus x must be greater than 0. Now, move the x another side. So we have 3 greater than x. So we can conclude x less than 3. This is the domain. This is the domain. X must be less than 3 or from minus infinity to 3, like this. What's the meaning x less than 3? Less than 3 to minus infinity. So any value from minus infinity to 3, this is can be substituted in f of x. But other than the value inside the len equal negative, and this is not in the domain. Okay, any question? So if we need to find the domain for the logarithm, for exponential R, the domain R, because the domain from minus infinity to infinity, this is directly. But in logarithmic function must be the argument positive. So must we find the value of x that become inside the len or logarithm positive. Any question? Any question about this example? Wait. More properties about the logarithm. If we have logarithm x multiply y, so we have the product between two brackets, two variables, x and y. We can distribute the logarithm for the first and the second, but put it plus between them. So logarithm x plus logarithm y, because x and y multiply together. If we have a fraction, logarithm x over y, we can distribute the logarithm on the x and y, but put it between them minus. So logarithm numerators minus logarithm denominators, logarithm x minus logarithm ly. Each logarithm with the same base, b, b, b. Okay, the same base. Now, if we have exponent, for example, x to the power p, so we can put it the p outside the logarithms. This is already studied. If we have, for example, like this, logarithm lx to the power 5, this is equal 5 logarithm lx, like this. Put it the 5 outside the logarithm. In product, if we have logarithm or len x plus 5 multiplied by y minus 1, we can distribute the len x plus 5 minus len y minus 1, for example, plus. Okay, if we have, for example, len 2x, or sorry, x to the power 5 over y square, we can distribute the len in the numerators minus len in the denominators. Also, we can continue for more simplified to put in the one variable without exponent inside the logarithm. So we can put in the exponent 5 outside the len by multiply, and 2 put it outside the len and multiply with len. So we have the result 5 len lx minus 2 len ly, like this. This is more simplified. If we need to more simplify, must be put the variable, the value x or y inside the len with power 1. Okay. Any question about this properties? So if we need to find the simplify for this means logarithm 9 to base 3 plus, because this is product, plus logarithm y to base 3, and we can put it 9 as 3 square. Okay, so we have, wait, here we have logarithm 3 square to base 3 plus logarithm y to base 3. Okay, this is equal, and we can remove 3 with 3 or put it 3 outside the logarithm like this. So we have 3 to base 3 plus logarithm y to base 3. This one equal 1. This is equal 1. So we have to multiply 1, 2, and logarithm y to base 3 like this. Okay. If we have a fraction, logarithm 10 with base 10, this is common logarithm minus logarithm t. Also, the 100 is equal 10 square. So we can put it the logarithm to 10 minus logarithm t like this. This is logarithm 10 to base 10. This is 1. 2 multiply 1, so we have 2 minus logarithm 10. Also, this is, we can convert the radical to 1 over 3 w ln w 1 over 3 and put it 1 over 3 outside the ln. So we have 1 over 3 multiplied by ln w. Look at this also. We can distribute the numerator and denominator. So we have logarithm 5x to the power 7 minus logarithm radical y, and distribute the logarithm 5 plus logarithm x to the power 7. This is a product because this is a product, and the y radical y equal what? Y to the power half. Now we can put it the 7 multiplied by logarithm and half multiplied by logarithm. So we have log 5 plus 7x minus half log y. Y, Z, W with power 1. Okay? For more exercise about this, logarithm or ln 3 x to the power 3 multiply y square over 5 z to the power or radical z. If we have fraction and multiplication in numerator and multiplication in denominators, we can directly distribute the ln in numerator and denominators. If we distribute in numerators, put it ln plus ln plus ln. When distribute the ln in denominators, put it minus ln minus ln minus ln. So we have directly ln L3 plus ln x to the power 3 plus ln y to the square. This is the numerators. Now we need to distribute the ln in denominator. So we have minus ln L5 minus ln radical z like this. Minus in denominators, plus ln in numerators. So this is equal ln L3 plus 3 ln Lx plus 2 ln Ly, put the 3 outside ln, 2 outside ln, minus ln L5, and this is z to the power half. So put it half outside the ln, like this. Any question? Now, if we need to sum or difference logarithm to written in single logarithm, so we have many logarithm or len, we need to put it in one logarithm, in single logarithm. Look at this. We have c x square minus b square a plus b, but you must check the outside of the len. This is positive or negative. If we have plus len, this is in numerator directly. If we have minus len, this is in denominators directly. For example, if we have len LA plus len LB minus len LBC minus len D. So this is directly len LA multiplied by B over the denominators C, D. Because this is negative, this is in the denominators. Because this is positive, so this is in the numerators. Okay? Plus len. So inside the len in numerators, multiply together. Minus len, this is in denominators. So C multiply by A square minus B square like this. This is in numerators minus A plus B. So this is in denominators. Now A square minus B square, we have different square. We can put it A plus B and multiply A minus B and remove A plus B with A plus B. So we any question? Any question? Now, if we need to change the base, we can put it log x and log b with a new base. So, for example, logarithm 5 to base 3. We can put it this as log with 5 to base 10 over log L3 to base 10. Or we can put it len L5 to base E and len L3 to base E because len logarithm to base E. Or we can use the natural logarithm, common logarithm, or any base. For example, we can put it log 5 to base 2, log L3 to base 2 also. Okay, so, but in general, use the len or logarithm because in programming language, using natural logarithm or len, So how can find the log L3 to base log L5 to base 3? So we need to change it by using the common logarithm or natural logarithm, using the len or log to base 10 to find log L5 to base 3. Also, the old calculator have logarithm and len, but a new calculator have log argument and put it base. This is a new calculator, but the old calculator using log with base 10, this is common logarithm, or len, this is logarithm with base e only. Also the a programming language, some programming language have this one and this one. Cannot calculate, for example, 5 to base 3. So we need to use this one or this one. Look at this also. How can calculate this? or compute this by programming language. This is using the natural logarithm log 806 over log 2 and find the value of this. Can use the logarithm. We can use the logarithm or natural logarithm. Okay. Now, about equation for exponential equation, if we have the same base, so must be the exponent are equal. For example, if we have x equal to, 2 to the power x equal 2 to the power 5, so must be x equal what? 5. Okay. Or 2 to the power 3x minus 1 equal 2 to the power 5. So we can conclude 3x minus 1 equal 5 also. Okay, or another 5, for example, 7. Okay, so we have 3x equal 8 after move the negative 1 to another side by divide by 3, so we have x equal 8 over 3. This is the value of x. Exponential equation means the x in exponent. The x, you can find the x in exponent. Okay. Now, sometimes we have two numbers, for example, 27 and 9. We can convert 27 to 3 and 9 to 3. Okay, so 27 convert it to 3 to the power 3, and 1 over 9 convert to 3 to the power negative 2, because the 9 3 square, and move 3 squares or rising to numerators, so we have negative exponent 3 to the power negative 2. Okay, power product multiply power, so we have 3 multiply minus 2 minus 6, 3 multiply 1 3, and minus 2 multiply x minus 2. Now we have the same base, so we have the same exponent also. Minus 6x plus 3, this is equal minus 2x. So we have minus 4x equal negative 3 by divide by negative 4 for both sides. So we have negative 3 over negative 4. This is equal 3 over 4. This is the value of x. Okay, any question about this? Any question? So must be the convert two base in the same number. So we can find the relation between 4 and, for example, 8. 4 we can convert 2 to the power 2, 8 2 to the power 3. Okay. Also, if we have logarithm equation, if we have logarithm with the base b, so must be the argument are equal. The argument must be are equal. So if we have log to base 10, so this is the argument must be equal. So we have 5x minus 1 equal 4x plus 6. Move the minus 1, we have 7. Move the 4 equal negative 4. 5 minus 4 equal x. So the value of x equal 7. Sometimes cannot find the relation between both sides like this, or for example 2 to the power x plus 1 equal, for example 3, like this. We cannot find the relation between 2 and 3. Cannot convert 3 to 2 to the power number or convert the 2 to 3 to the number. Okay, so in this case, take the length for both sides. Take the length for both sides. So we have length 2 to the power x plus 1 and length for 3. Okay, after that, this is exponent, put it outside the length. So we have x plus 1 outside, length 2 equal length L3. Firstly, move length 2, so divide by length 2. So we have x plus 1 equal ln L3 over ln 2, like this. Now, put it the 1 to another side, so we have x equal ln L3 over ln 2 minus 1. This is the value of x. This is another example, okay? This is another example. Okay, here take the length for both sides. So we have ln 5 to the power x, ln 413. Put it the x outside, divide by ln L5. So we have this one. This is the value of x. Any question? If we have two logarithms, how can solve the two logarithm? For example, like this, logarithm x minus 5 equal 1 minus logarithm x minus 3. If we have two logarithm, must we put the logarithm in the one side? Okay, so we have this one. This is equal 1. And put the logarithm in single logarithm. So if we have many logarithm, put it in the single logarithm. So we have, this is plus, so this is multiplication between them. So we have x minus 5 multiply x minus 3. Multiplied together, this is two brackets, so we have this logarithm. This means the argument equal what? 3 to the power 1. 3 to the power 1. This is equal 3. Put it 3 in the left hand side, so we have the quadratic equation x squared minus 8x plus 12. After solve this quadratic equation, we have x equals 6 and x equal 2. In logarithm function or logarithm equation must be check. So if we check the 6, this is positive, and here positive. But when substitute 2 here or here, we have negative. Inside log L3. Because after substitute 2 minus 3 minus 2, 1. 2 minus 5 minus 3. So we have an argument, or inside the logarithm, we have negative. So this is removed. Must be removed x equal to. This is not solution. So we have only one solution. One solution, x equals 6. Okay? Any question? Are you know why remove the 2? The x equal to? Hello? Okay. Now, this function y equal y naught e to the power kt. This function called exponential growth. هذا called exponential growth or exponential decay. Growth if k positive, decay if k negative. Growth and increase, so the k must be positive. Decay, this is decreasing, so the k in the power of the e, this is negative. Okay, now also we can any exponential, for example b to the power t, we can convert as or rewrite from the base b to base e by using e to the power ln b multiplied by t, ln b multiplied by t, because we can put it t or we can put it e t ln b like this, because we can put it t as exponent and remove like this, then b to the power t and remove ln with e, so we have b to the power t. Okay, so b to the power t, we can put it like this, e to the power t multiply ln lb. For example, 2 to the power t, we can put it e to the power t ln 2 like this. Okay, or for example 5 to the power t, this is equal e to the power t ln l5 like this. This is the same. Now for the exponential decay or growth y equal y naught e to the power kt, the population in Virginia was 7.1 million. Okay, so this is the y naught, the initial value 7.1 in the year 2000, and grow 8 million. So we have 8 million in the after 10 years from 2000 to 2010. Okay, now right middle of the form, this is form like this or like this, where b the represent initial population, this is 7.1 million in the 2000 year, in the year 2000. So this is the initial, and we need to find the k. How can find the k? From another given in the future. For example, we have 8 million after 10 years from years 2000 to years 2010. So after 10 years we'll have 8 million. So firstly divide by 7.1. Look at this, we have 8 equal 7.1 e to the power 10k. Firstly divide by 7.1, so we have e 10k equal 8 over 7.1. Take the length for both sides. After take the length for both sides, length le 10k equal length l8 over 7.1. Remove length with e, so we have 10k equal length l8 over 7.1. By divide by 10, we can conclude k equal length l8 over 7.1 over 10. This is the value of the K. Okay, so we have K 0.0119. So this is the populations after T years equals 7.1 e to the power 0.0119 multiplied by T. This is the year. Now this is just for convert. If we need to convert this exponent by e, just put it this one as like this. We know the b to the power t equal what? E t multiplied by ln lb, like this. So firstly put it this value as, look, 0.5 to the power what? T, all to the power 0.03. So convert this one to exponential, so we have 400 e to the power t fill in 0.5, all to the power 0.03. Now swap between t and 0.03, so we have 400 e to the power 0.03 fill in 0.5. Okay, all to the power t. Now this is we can multiply 0.05 multiplied by ln 0.5. We have some value. You can calculate them by calculator. So we have minus 0.0208 multiplied by t. So convert the y from with base 0.5 to base e. If we need to convert to base e, we must use this one. The last subject, logistic growth function. This is the last subject. This is the function between two values. The maximum value equal c, the minimum value equal c over 1 plus a. So the maximum here, maximum c, minimum equal c over 1 plus a. So this is called the logistic growth function by c over 1 plus a to the power p minus e to the power minus bt. Okay, example about this. This is example. So the maximum, the function, go to the c or 42.6. Okay, and this is the minimum. Divide by 1 plus 9, this one plus 9, because the when x, for example, goes to the or equal 0, so we have e to the power 0, 1. So this is equal, divide by 10, 4.6, 4.26. This is the minimum, 4.26, because divide by 42.6 over 10. Okay, so this called the function in this formula c 1 plus a e to the power minus bt. This is called logistic growth function. So the function between two values, the maximum C and the minimum C over 1 plus A. Okay, and the B, this is the curve. This is the curve of the B. So when increase the B, so we have like this. This is the B, okay? If we small the B, so we have, for example, B equals 0.01. So this is like this. We have curve like this. But if B big, we have the curve like this, and B are larger. Okay. Any question about this function? Just this is the this is called logistic function, logistic growth function, the maximum C, the minimum C over 1 plus A.